Welcome to the Passive House podcast, brought to you by Passive House Accelerator, a catalyst for zero carbon building. For news, inspiration, and connections from all flavors of Passive House, check out passivehouseaccelerator.com. Sign up to receive regular updates about events, get your technical questions answered, and contribute to the community forum. There's loads of free information for experienced professionals and people just starting out on their Passive House journey. We hope to see you at one of our construction, tech, or weekly Global Passive House Showcase webinars. In the meantime, here's this week's Passive House podcast. Right. Welcome back to another episode of the Passive House podcast. I'm Matthew Cutler-Welsh, coming to you from Auckland in New Zealand.
And I'm Zach Semke, coming to you from Seattle, Washington.
How are things going in Seattle, Zach?
Seattle is good. So we're in the early days of fall, and this is a beautiful time of year here. The heavy rains have not really, or the constant rain. We don't really get heavy rain in Seattle. We just get constant rain. The constant rain has not started. We are getting some moisture though, which is nice. So we're kind of out of the drought space, but it's crisp and sunny and beautiful right now.
I emptied my rain gauge the other day, and it had 100 millimeters of water in it. I don't know what time period that was. I think it was a few days since I'd emptied it, but we've had some serious rain here, which will be quite good because our reservoirs were looking pretty low. Yeah. So it is nice to get a bit of moisture, but things are starting to warm up. Springtime in the air.
Yeah, right.
Which people are out and about enjoying here in Auckland, despite the fact that we are in another lockdown at the moment.
That's such a bummer. I'm so sorry.
But coming out the other side of that, and I have to say that the building industry is going strong. There's still a huge amount of work out there. People struggling to get people because they just need more staff, more builders, more everyone, and also some product supply constraints around the place as well. But yeah, things are really trucking along.
Yeah, they are here as well. In fact, Construction Tech Tuesday, the episode this week will be with James Hartford, and he's going to be talking about creative ways to build passive house during supply and labor shortages. So looking to alternative building systems to make that happen, because I think a lot of practitioners and the homeowners, builders, developers are experiencing that.
Yeah. Well, we're going to great interview today. I was really excited to get Jason Quinn on this show. I've spoken to Jason a number of times, had him as a guest on my Homestyle Green podcast. But before we get into that, we've got some great sponsors to thank for bringing us the Passive House podcast.
Indeed. Our sponsors support everything that we do here at the Accelerator. We wouldn't be able to do any of it without them. So a big thank you to our founding sponsors, 475 High Performance Building Supply, Baxt Inqui Architects, Glavel Foam Glass Gravel, Minutair All-in-One HVAC and Dehumidification Units, Mitsubishi Electric Train HVAC US, Partel, RDH Building Science, Rockwell North America, Stillcorp, and Zola Windows. Our champion sponsors are Icon Windows and SIGA, and our stakeholder partner is NYSERDA, the New York State Energy Research and Development Authority. So thank you, sponsors.
Great. Thank you. And thanks, as always, to you, our great audience out there as well. Really appreciate all your energy and your time listening to this, and also the other great events available at the Accelerator. Jason Quinn. Let's talk about Jason Quinn. I'm guessing a lot of our audience probably know Jason or have heard of him. I guess have you heard of him over from North America?
Well, I have heard of him through you, and then I'm familiar with his work, and because it is that repository, compendium of details
Yeah.
that he's going to be talking about is something that I think a lot of us in the community are aware of and have a lot of respect for. I was really impressed listening to his insights and his smarts.
Yeah. He is a smart guy. Our running joke here is that he's a rocket scientist because he was formerly a NASA engineer, and
explains that.
So he does talk a little bit like you, Zach. He's got an American accent. Despite
he does, I appreciated that. I was about to be really, really flattered that you were saying that I spoke as if I was intelligent, but now I know you're talking about my accent.
He lives in Wanganui, which has been the Passive House capital of New Zealand. It's a relatively small place on the west coast of the North Island, but for some reason there's a few Passive House enthusiasts around that part of the world. And Jason's one of them. He's been involved in the Passive House scene since its inception here in New Zealand. He was one of the first people to be trained as a designer and was involved in the first house to be certified in Australasia that was here in Auckland. And he went on to become the first certifier. And for many years, he was the only certifier in New Zealand, and also certified quite a few of the early projects in Australia as well. He's been a leader in the field, and recently has produced he's produced a couple of publications. One was a book of the first 20 or so certified houses to be built in New Zealand, and Australia produced something similar as a follow-up to that. And he has also recently produced a publication of high-performance construction details, and as well as being great to read and full of amazing technical information, both of those publications are completely free. Which is incredible. So you can go and just download a PDF version, and you can also, if you're local, you can actually get yourself a hard copy version as well. But pretty amazing stuff from an amazing guy. So to talk more about that and some other exciting work that he's been done involving the New Zealand Green Building Council, here is my chat with Jason Quinn. Well, it's great to have you back on the show and talking to you again. Last time we spoke I spoke to you. We were talking about your Passive House book, which was released 2 years ago, I think now, which at the time showcased the 20-odd Passive Houses certified in New Zealand.
That's correct.
And I think as pretty much as soon as it was printed, it was out of date, but it's well out of date now.
Yeah.
So you're working on volume 2?
Not at the moment. That's not a bad idea, though. I think the next time it comes out, it won't have every single certified Passive House.
Yeah. And did you work on something similar in Australia, or did they just steal your idea and do something the same?
They didn't steal the idea. They asked if they could use the idea and the content.
Yeah.
So I explained to them that they would need to adapt the content. So they hired the same editor out of Wanganui, actually, and the same graphics designer to do their version of the book as well. So I told them they could have rights to all the content to use as they see fit, and they've taken and modified it quite heavily. So it's their own book. It's well written, so it's their own thing.
So in the last couple of years, you've been pretty busy on your work as a certifier here in New Zealand, but you've had a few other projects on the go. Tell us about the first one, which is the high performance construction details. How did that come about? And for those that haven't seen it or maybe glanced at it, how do you describe it?
Yeah, so a long time ago, like 8 or 9 years ago, you look at detail books from overseas, And it'd be like great to have these detail books kind of New Zealand defined, made into the same construction systems we use here. I remember talking to Claire actually from Australia about that when I was taking the Passhouse Designer course back in, I think it was like 2011. We took that class. And so it's been an idea that's kind of long been in a lot of people's minds, not just mine. And a couple of years ago, I mentioned after I'd done the Passhouse New Zealand book, I mentioned that I'm trying to get some manufacturers together to kind of get some money together to fund this idea. And I'm not sure who. I think it might have been Elrond, actually. Elrond Burrell, the current chair of Fins, suggested, hey, we could probably get some money from brands if we put together a proposal. And so that's where it came from. So, and it's kind of neat because it kind of grew. So we'll talk about what it is. But what I had in view was a very limited thing. Just a bunch of two-dimensional details done in Flixo and Therm with, thermal images and what the technical values are for those constructions. And that's all I wanted to do, really. And then, but the idea kind of grew. So it became, we should put some guidance in as well. And we should put in embodied carbon, and we should get a quantity survey and put in costs. So it's become a much better book because of that. It also helped that the building research levy came along to the party with some money, which is nice. So it ended up paying for probably, it might have been paying for almost 30% of the cost, which is pretty good, actually. So the book is a compendium, is what I used to call it. And it's a details book. So it's got 101 details in it. And those details are in two categories: elements, which are like walls or roofs or floors, which are assemblies of stuff. And then junctions, which are like where a wall meets a floor, or a roof meets a wall, or a window installed detail. It's a junction. So there's a collection of code compliant in New Zealand, like legally the worst you're allowed to build legally in New Zealand kind of thing, as well as Passhouse, as well as some stuff in the middle of different junction details. And so it's a fairly large. It took a very long time. Actually, I'm still working on some tweaks and revisions that are being suggested by different people. So imagine we'll come up with another version fairly soon. Although that version won't be an upgrade; it'll just be a refinement.
I can see it being a living document as more people try different things out with local materials and techniques. Some of the things you mentioned there, like embodied carbon, and even things like FRSI values and thermal bridge calculations. Did you have an idea that there would be an interest in those things back when you started? Because people are interested in them now, but how did you know that was going to happen?
Well, like most people, I work all the angles. Like, you don't just take a linear path through life. Like, you do many things as a person in life, right? You're an engineer, but also you're a dad. You're also play Frisbee or whatever, right? And you have all these different things that weave together. So when you're doing a project, you don't just do one thing. So I was talking to Elrond about getting funding for the book, but I was talking to Sam Archer at Green Building Council about, Homestar 5 and the use of Passhouse for that. And I was also talking to the window industry guys about how they should design their frames so we can meet this FRSI criteria from overseas to keep condensation and mold out of our buildings. And so, like, I was talking to a whole bunch of parties, and I knew that everybody was kind of heading down this path. What I didn't know was that Building for Climate Change was going to come out like that. And also the latest MB or change in the building code in New Zealand, where they're going to upgrade the building code significantly. So all those pieces, plus the big changes of MB kind of swinging in with the big fish, really brought folks' attention to things like FRSI, which is being motivated primarily by Homestar 5, version 5, out of Green Building Council. And then also this update to the building code, we're potentially having much like international standard R value requirements for roofs, walls, and floors and windows. All of a sudden, the industry was super interested in higher performance constructions. And it just timed out that I had this book in draft form available just about the time that H1 review came through. I think it's likely brands knew about it, and that's why they agreed to give us money. But they didn't tell me, so I kind of was just happily surprised. So thank you. Whoever made that happen, thank you.
Well, I think the whole industry is saying thank you, because there's this amazing resource that you've created now with the various inputs, and it's free. I mean, that's the incredible thing, is it's such a valuable resource, but people can just go and download it. I want to stay on FRSI value for a little bit, because I still struggle to explain it in terms that my 9-year-old would be able to understand, which is a good sort of target for communications. Do you think that the industry in general is ready yet to learn about concepts like FRSI values and the details of thermal bridging?
Yes. Yeah, I do. First of all, the worst thermal bridges in buildings are around windows and window install details. And unbeknownst to me, but John Burgess at Brands and a whole bunch of people in the Window and Glass Association of New Zealand have been pulling in the same ISO standards we use for Passive House, for thermal bridge and FRSI calculations and such. They've been pulling that in the industry for almost 20 years now. So it's easier in New Zealand than it is in Australia, just across the ditch, because in New Zealand, we use ISO standards as underneath all of our window and glass and door stuff. Now, to some extent, our building code doesn't say you can do that, but we do it anyways. Right. So we sort of, just the window and glass and door says, well, this is the right thing to do, we're going to do it, even if the code says something else. And we'll just, because the code did say, or you could use ISO stuff somewhere in the code. So they've been just using what I consider proper standards for a long time. What they haven't done is they haven't had the drive to improve their windows and doors to get this FRSI thing, which we should try to explain to your, did you say 9-year-old son? Yeah. So if I was trying to explain this to a 9-year-old, and I deal with a 9-year-old, friend of mine's got a 9-year-old son. And so I would say that, cold spots equals mold spots, right? So if you have a cold spot in a house, it's a lot colder than everywhere else, you get moisture. And because you have that moisture, you get mold growth, right? So, if you stick an apple on the counter and it dries out real fast in the sun, it doesn't go moldy. But if you stick it in the corner of a back closet, that apple gets all moldy because it's cold and stays wet, right? So cold spot equals mold spots. And FRSI is just a ratio between the surface temperature on the inside of whatever we're looking at in a building and the outside temperature.
Nice.
So it's just a ratio. So if the ratio is high, it means that, like close to 1, then it means the surface temperature on the inside is basically the same as air temperature and you're all sweet. The ratio is really small, like 0.1 or 0.2, then it's really cold, and that means you have a cold spot, which means you have a mold spot.
Cool.
So now all the science stuff is like, well, how cold is too cold, and what's the ratio you need to be in your house? That's really complicated, and we can worry about that another day. We've got a set of standards that Passive House Institute requires for certification at the moment for their buildings, and pretty much the whole industry agrees that those are likely conservative, and we'll lower them in the future as we get better science.
Yeah.
And I expect that to come out of Germany at some point in the near future.
So it's a dimensionless number, this FRSI value. It goes in theory between 0 and 1, but you can never have 0 or 1, but it's got to be somewhere in there.
Yep, that's right.
And it gives you an idea. And there are some lookup tables that we currently have, right, for what we should be targeting as a threshold for those.
Yeah, in the high performance construction details manual, there's a table for cities with what's required, and then in the I don't know if it's in Homestar version 5 manual or not, but we've also got a color map that shows those requirements for all of New Zealand.
Yeah.
For some reason, they didn't want the color map in the high performance construction details book, so I had to take it out.
Yeah. A couple of things there. You've also mentioned Passive House a few times and standards, international standards, ISO standards, in the background of what's been informing the building code. It kind of makes you think that this Passive House thing must really work.
Yeah, in my mind, it says that the ISO standards really work and are reliable, right? So Passive House itself, the Passive House planning package, the software tool we use in Excel, that is based upon a lot of these ISO standards, and they got to pick and choose which ones to use. So it turns out that the ones that the Window and Glass Association of New Zealand picked as an industry are the same ones that Passive House picked, which makes sense because they're international standards that have been quite well developed. Now, Passive House does modify them a little bit as they see fit inside of the Passive House planning package to make the results either a little bit more conservative because that's what they choose to do, or whatever. But in general, the whole Passive House planning packages is just an implementation of all these international standards.
Yeah. Which is nice. It should be comforting for engineers, designers, people that there is a consistency there and some rigor, some international rigor and scientific process behind. They're not just random numbers that are picked out that the industry can get comfortable with.
And unlike a lot of energy models or other things. It's not only a standard that you can work to as an engineer not to get sued because you've done it correctly per the standard, but also we know because of Passivhaus House and how it's taken on, in a large term across the world, that it's accurate enough. It's sufficiently accurate to give you results that are useful and predict the actual energy use of the buildings fairly closely on average.
So that brings me to the other project that you've been working on, which is related to Passive House Planning Package, and it's got a fancy name as well, ECHO, which is the energy and carbon calculator for homes. Tell us a bit about what that is from your perspective.
So ECHO is a wrapper that goes around the Passive House Planning Package. So effectively, if you think about Passive House Planning Package as this really complicated spreadsheet with, I don't know, maybe it's 40 sheets at this point that you fill out with things about the building, like its area and what it's made of, and how the heating system works and how the ventilation system works and all that stuff. All the windows go in there. But it's got a lot of different sheets you have to enter all this data into. And it's designed to give you to be as accurate as is reasonable for both a single family home as well as office buildings or even a hospital, right? But if you're doing single family homes, which is what ECHO tool is really designed for, or individual apartments, then you need a much smaller number of entries. And if you're willing to accept some simplifications, then you can get most of the accuracy of Passive House Planning Package with much fewer inputs. So what I tried to do is to have, originally it was a one-page spreadsheet that did a full Passive House Planning Package design for a very simple building. And so it's a simplified set of entry sheets for the Passive House Planning Package. Plus, we added a bunch of stuff that was custom for New Zealand Green Building Council, like the way the appliances are dealt with, or carbon calculations are done, or a reference building is done. So it was just all built in PHP with some custom entries up front. And then a lot of things turned into drop downs. So instead of entering a number for how air leaky your building is, whether it's 0.6 air changes 50 Pascal or 12 air changes 50 Pascal, it's now like, leaky as hell and, somewhat leaky, pretty good build. It's like, you can make anything you want, right? And then there's defaults. So some of the entries actually originally were like leaky as hell and somewhat better because I thought it was cute. And I knew that Green Building Council would make their own name up. So
leaky as hell also translates to standard code compliant.
Let's stop there. I'm not going to go in that one. But so leaky as hell to me meant 20 air changes per hour at 50 Pascal, which is effectively you left the window open. So it's a wrapper. And then the main simplification is that it assumes the building is, we take the building, we kind of smush it into a shoebox. So the walls have orientation and they have sunlight on them and such, and on the windows that go into them, but the building doesn't self-shade. So all the shading entries are entered just as percentages via a drop down where you pick, building in a cave. I think one of the entries is in a cave, or at least it was originally. In other words, fully shaded to, hardly any shading and then somewhat shaded. And by doing that, you get everything else is effectively a full Passive House model. Like the entries for the constructions are all fully folded into Passive House. The ventilation system is fully folded in, that sort of thing. But the big simplification is on self-shading and on the building form.
So really it's bringing the power of PHPP and the maths and the calculations that are embedded in that big spreadsheet, but to a simpler interface. So there's fewer, so it's a little bit coarser in terms of the inputs, but that means that the modeling time is drastically cut down. Is that fair? Yeah,
that was the plan. Yeah, so you can even put in a shoebox model where you have a building with 6 sides, and you might put in 40 windows. So you can model an apartment building in 20 or 30 minutes. To get a coarse output.
And this is all.
So and you can step on into a full Passive House Planning Package model, right? So it's a good gateway drug. Is that a positive thing or a negative thing?
It's a gateway. Gets people.
It's like, I don't know. It's like the free candy they give you at the store, so then you buy more candy. Yeah, it's like free candy. Let's go with that. I don't like the dairy.
And this is all done with the blessing of the Passive House Institute.
Correct, which means that everybody has a copy of ECHO has to have a full license to PHP.
Yeah, and
access to
which I'm really excited about. I think I'm hoping that it will be a gateway for people, because it's opening the whole industry up to the potential for PHPP and Passive House if they want to go, because they'll have access to that. But it just gives them an idea of, because I guess just to put things in context, I mean, the average architect, the average builder in New Zealand has been pretty limited in what they've been required to do, and the tools that they've had access to have been very, very basic in terms of just simple. I mean, well, even if they had to calculate anything, they could just look up at a schedule method and say, well, this level of insulation is enough. But if they wanted to go a step further than that, the tools that they've had available to this point have been super, super basic.
Yeah, I mean, on top of that is you've got a well-meaning builder and architect that can kind of get a sold a bill of goods by manufacturers.
Yep.
Because they don't know that if I buy, like in this house, the way it's designed, I've designed as an architect, you don't know if it's worth going triple glazing or double glazing. What's that do to my building?
Right.
Whereas that's a really easy question to answer with Eco, or with even easier with PHP. So the one, like we talked about, there's a little simplifications in Eco, but they become more and more important as you get down to the passive house level. So when you start getting down to 15 kilowatt per square per annum, or even down below 20 or so, it's much more sensitive to shading and form in the building. So that's where you might want to transition out of Eco into PHP. But for quick studies to see how things impacted, to see if a manufacturer is selling you something that you need or not, it's really good for that.
A couple of things there that I hope is going to open up designers to. One is overheating, which you've kind of alluded to with the shading. So because you don't even have to account for that in our existing building code, which is kind of crazy, but we're seeing a lot more overheating happen, and that's kind of makes sense. So to be able to account for that or predict it is huge. And the other one is the impact of infiltration, and being able to see when that starts to have an impact on a building, and when you start to get diminishing returns from just simply adding more and more insulation. So I'm excited to see how designers use that and start to play around with things. Like you say, they can run cost-benefit scenarios on different options.
Yeah, and it makes it really quick and easy for them to do that. And I did build into the shading sheet in Eco overhangs. So you can, like, for example, one of the things I commonly have is we'll have architects would put a deep overhang on an east and west facing window, and they'll complain and they'll get kind of grumpy with when I tell them, well, those windows are causing the building to overheat. And so in Eco, it's easy to put in, you can put overhangs on the building, not just percentage shading on the shading sheet. And you can see that if I take that window and I rotate the building, because you can rotate the building in Eco, you can just change the angle on the front sheet. And you can rotate that window, or you're building with one window and an overhang, and see how when that window's facing north plus or minus 5 degrees, the overhang's brilliant. But once you swing it 15 or 20 degrees off north, or even 45 degrees off north, the overhang does nothing. Doesn't really help at all. So you can actually do that yourself now and see that, instead of having to trust some cranky American.
Well, that's an important point, because a lot of people assume that for us here in the Southern Hemisphere, it's the north-facing windows that are the problem, and in the Northern Hemisphere, it's the south-facing windows that are going to cause the overheating. But it actually tends to be the westerly-facing east and west. You get the morning sun at that low angle, and then at the same in the evening time, the sun at the lower angle. You can have as much EV as you like, but if unless it's like a vertical kind of shade, it's not going to do anything for you in the evening.
That's right. Yeah.
So it's exciting stuff. And you mentioned that's going to be built into version 5 of Homestar. We're going to wait and see how that goes. Obviously, I've vested interest in that now, working with my role at the Green Building Council, which I'm very excited about. And having that Echo tool is a big part of why I am doing what I'm doing now, because I see a huge opportunity for that. So I think it is really exciting. Has this been done before, this type of thing with PHPP in the background?
No, this is the first time PHI has agreed to something like this. So it took more time than to build the tool by a good factor to get PHI and Green Building Council together and all enjoying each other. So it's only because the folks at Green Building Council and at PHI and I have been friends for a long time, so we can trust each other. And of course, we have contracts to make sure we understood each other clearly. And Green Building Council has signed those contracts, not I. But for Passive House Institute, the PHP is their crown jewel.
Yeah,
like the core of their entire business model, as well as their intellectual property. So to share it with someone like this is pretty spectacular, actually.
Absolutely.
It's a pretty awesome thing to do.
Yeah.
And so it's really good that the team at Green Building Council was able to talk into it.
And as on top of all that, you've carried on your other work. You've got expanding the team at Sustainable Engineering, and we've got more certifiers in New Zealand now, which we need because we're getting more and more passive houses and passive house projects certified. How big's the team there now?
So we've got 3 passive house certifiers. So myself, Toby, and Sarah. And then we've got a technical drafter and an admin person. So I guess that's about 4 technical staff and an admin. So not that big, so fairly small.
And on passive house in general, can you give us a quick update on where we're at with other typologies in New Zealand that are coming to fore? Because your book 2 years ago, it was all standalone single dwellings. I think the co-housing project was in there, but it hadn't quite been finished yet. But where are we at now, including social housing?
So certified right now, we've got the co-housing complex down in Dunedin has been certified.
Yep.
So High Street. And then and we've certified a small office in Upper Hutt. So that's been certified as a passive house.
First commercial building.
Loan as you building. Yeah, so loan as you building, I believe.
Awesome.
I'm pretty sure. Yeah, it is. And then so we now have a commercial building, we now have a co-housing complex. And we've done a few duplexes now, but that's been about it. So most everything else is still single-family home. Now, as far as stuff that's gone through pre-construction approval, so when people are doing certifications, actually pretty much every certifier worldwide really tries to get everybody to do all the work up front. That's kind of this whole front-loaded design process. So that if you're going to have somebody certify the building, you want them to find the mistakes before you build it, because then it's easy to just say, oh, we'll change the way the install is instead of tearing all the windows and start over again, which is the other option. So we've done pre-construction approval on a lot more social housing projects, including a couple in Dunedin, some pensioner flats. There's Bonaventura, which has been announced, which has been through pre-construction approval already up in Auckland, which is Kainga-Ora's first passive house certified project. So they're targeting certification still at this point. They haven't been certified, but they've been through pre-construction review.
That's pretty massive, though. I mean, it
is. Although I'd point out, much to Kainga-Ora's chagrin, that they're slightly smaller than the co-housing in terms of.
Oh, right.
I think in square meters they're bigger.
Right.
But I think because there's a couple of single family.
But it's a huge step forward in terms of the acceptance of passive house in New Zealand, given that it's the national provider of social housing, looking at and seriously embracing passive house as an option for their tenants.
Yeah, so I put an article out in our newsletter, which came out, I want to say yesterday or the day before, Tuesday this week. And so I put an article together. It's basically got a preliminary case study for Kainga-Ora's project, Bonaventura. Yeah. So it's got all the U values and the windows in there and all that stuff that people, technical geeks like us, like to look at. So that's available on the website if you want to take a look at that. And as I said in that article, I'll say again, which is, to me, the Bonaventura is huge, right? But it's not. It's actually Kainga-Ora's laying out their carbon continuum. So they've laid out saying, well, we want to get to this building for climate change target by 2030 or 2050. I forget what the dates are. It's on the continuum. So therefore, we basically cut our contracts 5 years before the building's built.
Yep.
So, and then we have to sort it out 2 years before that. So we have to start 7 years in advance. So if the target's 2030, we don't actually have till 2030. We actually have to 2023. Yeah. It's 2021. It's nearly almost 2022 already. Yeah. So they've only got like a year and a half left if they're going to hit something in 2030, right? So that's why, so they've said this and said, oh shit, let's fix it. So they've got Bonaventura and they've got other projects which are on their continuum, which you can see on there. I'll let them release any other information they want to release later. But so they've got other projects they're working on. And I think that to me, that's that has a real potential to shift the New Zealand building industry.
Definitely.
Because there's such a large consumer of building products and they've got so many projects across the country. They don't employ like 1 or 2 big state builders. They employ every little builder across the country can work for Kainga-Ora. And I mean, if they're big 3-story walk-ups, they want the the best of the builders. But when they're building a single family home in Tuana or in Wanganui, the local builders all tender for that project. So.
It's huge. It's huge. And we're very lucky to have people like yourself, Jason, helping to facilitate that, because they'd be struggling without you and all the resources that you've provided. So I'll take this opportunity again to thank you for doing all the fantastic work that you've done and are continuing to do with your team as well. So I look forward to more coming out of the Sustainable Engineering Office.
We'll do our best.
Awesome. Hey, well, and thank you for your time today as well. I really appreciate it. All right, there he is, Jason Quinn, our former rocket scientist turned passive house professional and guru here in Wanganui, based in Wanganui and the North Island of New Zealand. How was that, Zach?
Oh, it was fantastic. Thank you for bringing this interview to us. And man, I love the cold spots cause mold spots, or cold spots are mold spots.
Yeah.
What a simple way to convey building science.
Yeah.
In evocative and great for 9-year-olds and also people like me. It's perfect.
Yeah, FRSI values they're quite fascinating because you spend a bit of time on things like that during, if you're lucky enough to go to passive house designer consultant training, and it's kind of going to rock the world of the building industry here in New Zealand, because we have a fairly limited building code at the moment, and you can get by with just basic knowledge of insulation. Really, you can just buy stuff with a high enough R value, and that's pretty much all you need to do. So things are coming down the pipe where the designers and builders are going to start to have to think about things like airtightness and FRSI, possibly not for the mainstream, but certainly if they want to do anything that has a Homestar rating, which is our equivalent of a LEED certification here in New Zealand. Those requirements those are going to be required for a base level Homestar certification, and Jason has been instrumental in making that happen.
Sure, sounds like it. And the tools that he's also, or the Echo tool, I think we got to talk about that. I mean, that opens up so many interesting questions and possibilities, I think, right? And,
absolutely.
And there's all about this relationship between a comparatively loose code in New Zealand and the high bar of passive house, and this this a stepping stone with Homestar, and all the while with an agreement brokered with PHI, which is really really cool. So I'd love to hear more about your thoughts about Homestar, and then also you revealed some news as well about your professional life. So what's going on?
Yeah, so full disclosure, I am now working for the New Zealand Green Building Council, which I did over a decade ago. I was involved in when Homestar, which is our LEED version for houses, the residential market here in New Zealand. When that was first launched, I spent nearly about 3.5 years at the Green Building Council, and I've returned there primarily because of some of this exciting work that Jason has been involved in, because I see a huge opportunity to put some amazing tools based on PHPP in the hands of a lot more people. And that tool is the Echo tool, which Jason has developed along with Sam Archer, who's one of the directors at the Green Building Council, but also with the blessing of Passive House Institute, which is quite massive. Like you say, for context, the New Zealand Building Code, as it stands right now, is a fairly low bar, and that means that the gap between a code-compliant house and passive house is quite a big step. And it's awesome, and we're seeing a lot of traction there. It's fantastic, but we're still at hundreds of thousands of houses being built, and tens of those might be passive houses. So what Homestar now offers is a as Jason puts it, a gateway for people to access tools that are a lot more informative than just applying the standard code. And that will introduce things like air tightness and also these FRSI values and a number of other factors as well. But I see it as just a really exciting moment where we're going to be able to educate the industry and help consumers as well do some really good cost-benefit analysis at the front end of the design process.
Yeah, well, first, congratulations on the new position. That's super cool, and they're lucky to have you. And I'm excited to see what develops over the years here. And secondly, I just like for folks who are thinking about this, and maybe from a place like Washington State that has a fairly progressive energy code, or other places in the world that have a progressive energy code. And if you're a passive house partisan, like I sometimes feel like I am, then it's, I think, important to understand that that how different this context is. Because for me in Washington State, so I see some of the other green building certifications, at least on energy, as not all that meanable anymore, because they're so close to energy code already. I mean, they do have the broader, they do address broader sustainability questions and things. So that's valuable, but there's just not a big delta between energy code in Washington State and those certifications. So that's why for me here, passive house seems like let's just jump to passive house. But in New Zealand, you're really in a different place. Like, that's a very different reality. And so with the Homestar piece, you have this potential of really making progress at scale, and, as you say, creating this gateway experience for practitioners and ultimately homeowners and apartment dwellers. And so and so the Echo tool has two purposes that Jason was describing. One is that it can be really helpful to passive house practitioners and designers, because you can use it for quick analysis of design decisions, and maybe try out different ideas and get a quick result. And it has that utility for projects that are not quite, don't have the same super low energy consumption as passive house projects. It sounds like there's a sweet spot for the Echo tool that lands probably where Homestar is at.
Yeah. I mean, it's going to encourage people along the pathway of, for example, air tightness. So 0.6 air changes is great, but if you're coming from a place where you've never done air tightness before, then aiming for 3 is a really good step. And I don't want to hang around in that space for too long. We need to move people, we need to move the industry as fast as we can down to 1 and below. But this does that. And I think there's a risk sometimes that passive house can be just too audacious and too scary, so that it's easier just to ignore it completely. So having a pathway towards that, I think, is really beneficial, because then we know that once people start to do things a different way, it's very hard for them to go back to doing the thing the way they were doing them. So hopefully this does encourage people down that path and open it up to a much broader range of people, and particularly starting with social housing, which we talked about. And Jason mentioned working with MB, which is our ministry that includes the people that are responsible for the building and the building code here in New Zealand. And the fact that both them and our big social housing provider here, Kāinga Ora, are on board with both Homestar and also doing some passive house projects is a huge step forward here. Really exciting to see that progress. So we're getting passive houses beyond just single privately owned standalone houses, but a bigger diversity there, which again might seem not that big a thing for more developed markets like the North America market, but here, up until now, we've really only seen Passive House in single, standalone, privately owned homes. Super exciting stuff. And I just, like you mentioned there as well, I see the other benefit of tools like Lead and Homestar for Us. Green Star in Australia has just launched Green Star for Homes. That they do offer that whole spectrum of sustainability, including now embodied carbon. And that's going to be quite a big thing going forward, where people are looking at not just the operational energy and therefore the operational carbon of buildings, but also thinking about where materials are coming from. And Homestar for Us, I think Green Stars for Homes in Australia is looking at incorporating that as well, is really going to give people the tools to look at the embodied carbon of the building industry. So super exciting stuff.
Indeed.
All right.
It's sort of like a kind of a different sort of organic version of this whole step code idea, right? That we're taking steps toward where we know we need to go, which is Passive House for new construction.
Yeah.
And leading and helping the market make that transformation.
Yeah.
So
hoping we can get there too.
Yeah.
Great. All right. We got a bunch of stuff coming up. Still a busy time of the year for events.
We do indeed. So the next big event that's coming up in the Passive House world is the FIASCon. So this was formerly known as North American Passive House Conference. This year, FIAS's conference is called FIASCon, and it's going to be held October 12th through 15th in Terrytown, and registration is open. This is an in-person conference, and I'm looking forward to being there. I'll be involved in emceeing a little bit on the plenary session and be doing interviews. It's a great program, and I hope that a lot of listeners will join us in Terrytown. And of course, we also have the Getting to Net Zero Forum that's happening on October 27th through 29th through the New Building Institute, and the South Pacific Passive House Conference, November 25th through 27th. So we'll share a link to all of that, those big kind of national/global events in the show notes. And at the Accelerator on Tuesday, I mentioned at the top of the show, Tuesday, and Wednesday, your time, for Construction Tech, we're joined by James Hartford of River Architects, and he'll be talking about building Passive House during supply and labor shortages and the role that alternative building systems can play in making that happen. And then on Thursday, your time, at the Global Passive House Showcase, we're joined by Alyssa Boucher of Rogers Partners Architects based in New York. And she's going to be talking about this really cool recladding project of a 20-story apartment building in New York. And, New York has its local law 97 that is requiring building owners to meet emissions caps that are getting more and more stringent over a time schedule over the next couple of decades. And so this is an example of how to take a very big first step toward being compliant with that, and really interesting Passive House insights around this. And we'll have guest host Andreas Benzing from New York Passive House with us as well. So awesome. Lots of great stuff. Please join us.
So much going on. All right.
Indeed.
Well, that's a wrap for this week. Thanks to all our great sponsors. Thanks for you listening to this podcast. Don't forget you can reach out, email us, podcast@passivehouseaccelerator.com. We'd love to hear from you. Thanks again, Zach.
Yeah, thank you, Matthew. Thanks for the great interview with Jason. Really appreciate it.